Okay, this is our last section in Chapter 5, and some of you are thinking, oh, thank goodness. But Chapter 6 is more complicated. Chapter 6 builds on what we've learned in Chapter 5. And then remember that we're only halfway through the book. And so next year, it's going to keep building. So you can't relax. You can't say, oh, we're done with Chapter 5. I don't have to remember all that stuff anymore. No. What we've been doing in Chapter 5 is going to be relevant. It's going to be important from now until after calculus. I mean, you need this information. This is not something that's going to go away. It's not specific to 7th grade. We need to know how to do this. So we're going to be looking at changing things and transformations. We've already talked about transformations, transformers, more than meets the eye. We're going to look at transformations with graphs and with linear functions. So we're going to start with something. There we go. We're going to start with a family of functions. It's nice. It's a family. A family of functions is a set of functions that all start from a very basic starting point, a basic characteristic. And so we've got linear functions. They're all kind of this family because they're all straight lines and they're not curvy. So that they're a family. You could have a curvy line. A quadratic family would be a U-shaped one. You got all sorts of different families. And for any family, it's important to have a parent. And so we have a parent function. We've got a starting point. All the other graphs, all the other functions start from the parent. And for linear functions, the parent function is going to be f of x equals x. Because f of x equals x has a slope of 1 and a y-intercept of 0. So it's your most basic linear function you could possibly have. It goes through the origin. It has a slope of 1, which is the most basic number that we could have. A slope of 0 and a y-intercept of 0 would really just not be much of anything. And so it doesn't give us much. So f of x equals x is our parent for this. Okay? And then we are going to transform this parent function, f of x equals x. We're going to transform that function into other functions. They're like mini functions. They look kind of like f of x equals x. They look kind of like the parent, just a different version of it. Kind of like you and your parents. Different version of the same idea. Okay, so we're going to be doing some transformations. We've talked quite a bit about transformations in the past, and we're going to transform that parent function, f of x equals x, into another version or another form of that same function. Okay, first one we're going to look at translation. Translations, we talked about this already. Translations where we move along a path. And so for a function, the slope isn't going to change. It's just going to move up or down. And so you're thinking, well, what about left and right? If I move this left or right, remember, it goes on forever. And so really, moving it left or right isn't even a thing because this line, I can't do it from here, but this line would continue forever. And since it goes forever, there is no left or right. It's infinity. So there is no greater infinity. Infinity is just infinity. And so it doesn't matter left or right. There is no moving it left or right. We just move it up or down. And so if I move this function up 2, let's say, the original parent function, remember, is f of x equals x. That's that parent function right there, f of x equals x. This new function, which was transformed, is going to have another equation. In fact, I'm not going to use f. I'm going to use g, because g is a different letter. It's kind of like f, but it's g. So we're going to say g of x. This new function still has the same slope, so it's still x, but it's got a new y-intercept. It would be f of x plus 3. If I then, I don't know if I can do this. Let's see if I can. There we go. So if I take a new function, so here's my parent again, I'm right on the parent function, and let's say I move it down 2. I moved it down 2. I'm going to have a new function. We'll go with h this time. H of x is going to equal still the same slope. You'll notice they're all parallel. Would be x minus 2. So the only thing that changes with the translation is not the slope, it's the y-intercept. The only thing that changes with the translation is the y-intercept. And so whenever you have a translation, we would say it translated up 3. So from f of x, from f of x to g of x, it translated up 3. From f of x to h of x, it translated down 2. And so that's how we would describe that transformation. It translated up or translated down, went up or down. Rotation. We're going to rotate this figure. We're going to rotate, and I can almost do it. It's not quite perfect, but let's say it rotates like this. So I've rotated that parent function. Again, my parent was f of x equals x, and I rotated it. So I rotated that parent function about 0, 0. You'll notice that that's where it's turning. It's turning around this point 0, 0. And so I would say that this function rotated around the point 0, 0. And we got this new function, g of x equals, and if I look, the y-intercept is the same, because it rotated around that point 0, 0, and the new rise and run would be a rise of 2, run of 1. So it would be g of x equals 2x. And so we can rotate that parent function. Around a certain point. And so even if I had, let's say I had this one here. I have at this point right there. Oh, I don't know if I can do this. We'll find out. Here we go. There we go. So if I've got this parent function, we'll call this one h of x. And this is going to be x. This would be minus 3. So if I rotate h of x, I can't quite get it. Nope. It should rotate around that same point. There, that's sort of it. It would rotate around the point 0, negative 3. So the first one, from from f of x to g of x, it rotated around the point 0, 0. From h of x to this other one, it rotated around the point 0, negative 3. And I'll do an example of that and how that would look in a problem here in a little bit. But that's a rotation. So it rotates around a certain point. Reflection. Reflection, just like into a mirror. So if I reflect this point, I think I can do it. Here we go. We're going to reflect that point. There we go. So reflect it. If the original function, the original parent function was f of x equals x, the new function after the reflection is going to be g of x equals negative x. Now, it's not always a 90-degree rotation. In this case, it is simply because of the slope. But let's say I had another line that went like this. So it's got a slope of 2. So h of x equals 2x. So if I have that equation and I reflect it across the y-axis, the new equation is going to be a reflection, which is redundant. But this point here is 1 away from the y-axis. It's 1 away from the mirror. So if I reflect it, it's going to be over there. This point here is 2 away from the mirror. It's 2 away from the y-axis. So the new point reflected would be over here. Same thing down on the bottom. This point would go over here. This point would go over here. And the point I'm trying to make is that it's not always a 90-degree angle. That it's a reflection, so it just ends up being the opposite slope. So let's say we've got what? F, H, G. I'm not going to do I of x, but pick your letter. We'll go with, I don't know, T of x. That's a weird one. So let's go with, we'll go with T of x equals, it'd be negative 2x. And so it's just the opposite slope. Not perpendicular, not reciprocal, but the opposite slope. So the 3 types of transformations. A translation either translates up or down. A rotation rotates around a certain point, whatever that y-intercept is. A reflection is just the opposite slope. That's it. Those are our 3 transformations. We're not going to do a dilation. A dilation would just make it bigger, but again, it goes on forever. It goes to infinity, so there is no dilation. Okay, a question that you would see looks like this. It says graph f of x equals 2x, so you would make a graph, and g of x equals 2x minus 6. Then describe the transformation from one graph to the other. So from f of x to g of x. I'm not going to graph it right here just for time, but if we're going to describe the transformation, if we look from f of x to g of x, we got to figure out how it got there. So first let's look at the slope. Did the slope change? No, the slope is the same, which means it's probably not going to be a reflection, probably not going to be a rotation. If the slope is the same, they're parallel. So it's a transformation. The slope didn't change. So if the slope doesn't change, and that might be a little note to write to your slope, slope didn't change. So if the slope doesn't change, it's going to be a translation. And it translated, well, from 2x to 2x minus 6. So it went down 6. So it was a translation down 6. You could say 6 units if you want. I'm just going to go with 6. Let's look at another one. Graph f of x equals x, g of x equals 5x. I'm not going to graph it just for the sake of time. Then we're going to describe the transformation. So again, from here to here, from f of x to g of x, how did we get there? From this one, the slope does change. It was a 1, now it's a 5. So the slope changed. So it could be a reflection, could be a rotation. A reflection, we said, reflected it across the y-axis, and we got the opposite slope, a negative slope. This one, they both are positive. It's 1x and 5x. So it's not going to be a reflection, must be a rotation. So if the slope changes and it's not the opposite, it's a rotation. So let's go with slope changed. Change number, maybe. Because the number changed, not just opposite. So if the slope changed number, then it is going to be a rotation. So it's a rotation. And we have to say what it rotated about. What point did it rotate about? And we're just going to rotate around the y-intercept. If we go back here to the rotations, for this h of x1, the blue line, the blue equation there, it rotated about the point 0, negative 3, right there. For the first one, it rotated around the point 0, 0. So this one is going to rotate around the y-intercept. And the y-intercept for both f of x and g of x would be 0, 0. That's it. That's right. It's rotation. I guess we could say rotation about or around 0, 0. For the last one, we've got graph. We've got f of x equals 2x plus 2. We're going to reflect the graph of that across the y-axis and write the function. So what would be the new function, g of x, if we did make a reflection? That's what they're asking us to write. Again, I'm going to ask you to graph it later, but for the sake of time here, I'm not going to graph it on the page. But we are going to write the function. So if it started with f of x, I want to know what would g of x be after a reflection across the y-axis. And we said for the reflection that the y-intercept stays the same. The only thing that changes is it's the opposite slope. Oops. So if I go back here, the y-intercept stays the same. The only thing that changes is that we take the opposite slope. So it would become negative 2x plus 2. And that would be the new function. So what I'm going to ask you to do is, again, I'm not going to ask you to graph at this point. Go ahead and try and describe the transformation for all three of or for the first two, I guess. The last one, write a function g of x to describe the new function. I'm assuming you did it. I'm assuming you got that, or at least you paused it and tried it. So if you were going to describe the transformation for the first one, it would be a transformation down 6. For the second one, ends up being a rotation around 0, negative 1. And if you didn't get that last part, the 0, negative 1, watch the video so we can see why that works. And the last one then, the linked video. The last one then, we've got a new function, so it would be g of x equals negative 2/3 x plus 2. Okay, if you didn't get one of those or any of them, make sure that you watch the linked video, and good luck on the form.